Hey, now that you've had a chance to work with those different types of conditional statements, it's time to go back to our reasoning. And if you remember from lesson 1, we had reasoning called inductive reasoning. That's the first type of reasoning that we looked at. Today we're going to look at a second type called deductive reasoning. So let's go back to inductive reasoning and review that. Remember that we did our conclusions for inductive reasoning based on making really careful observations and looking for patterns from several examples. And we led to a conjecture of what we thought would be true. Sometimes that conjecture was false, and we had to find a counterexample to show that it was false. In deductive reasoning, we still make conclusions, but instead of using patterns and examples, what we use is facts, things that are true. So these are facts. They might be definitions or postulates, but we need them to be facts. And we combine facts with the rules of logic, add those together, and you've got deductive reasoning, which means your conclusions are based on things that are true. And so when you come to those conclusions, if you've backed them up with the rules of logic and reasoning, then you have true statements. So that's the benefit of deductive reasoning, is you don't end up with some false statement. Now, what are the rules of logic? The first rule of logic that we're going to look at is called the law of detachment. And the law of detachment works pretty simply. Let me show you with this example. In this example, let's say we have a rule at school that says if it snows more than 5 inches, then there will be no school, so it's going to be canceled. And then suppose we get up in the morning and we see outside that we had 10 inches of snow last night. So is there some valid conclusion that we can make? Well, if we break this down, let's take a look at what the hypothesis of this statement is. The hypothesis is it snows more than 5 inches. And the conclusion that we see is there is no school. So if we write that in a symbol form, it's going to look like this. Snow greater than 5 inches leads us to a conclusion that there's no school. Now in our second statement, this isn't an if-then statement, this is just a statement. We got 10 inches of snow last night, but doesn't that tie back to our original statement? 10 inches of snow satisfies the hypothesis. If we got 10 inches of snow, then it definitely snowed more than 5 inches. So we have this other statement that says we got 10 inches of snow. Now, what valid conclusion can we make? The law of detachment says that we can fill in a blank, basically. What blank can we fill in? Well, since we got 10 inches of snow, I'm celebrating already. We have no school. So that's our valid conclusion. There is no school today. And we use this symbol. I'm going to show it to you now. It's these 3 dots in a triangle pattern. That symbol right there means therefore. So it's a shorter way to write this. So let's read through it all. If it snows more than 5 inches, there will be no school. Last night it snowed 10 inches. And then here's our symbol. Therefore, our conclusion is there is no school. Now let's try another one. Have you ever seen a sign like this from a store? No shirt, no shoes, no service? That could be looked at as an if-then statement. What is the hypothesis of that statement? It'd be no shirt and no shoes. So if I have no shirt and no shoes, I'm just going to write no S and S. No shirt and no shoes. Then what does the sign tell us? Is the conclusion? No service. So our first statement is an if-then statement. Now our next statement, it doesn't have the if-then format. It just tells us something about Sandy. And I'm going to highlight this the same way I did my hypothesis. Sandy has no shoes on. Does she satisfy the hypothesis? Absolutely. So what conclusion can we make? If Sandy has no shoes on, then what is the direct result of that? Well, the valid conclusion we can make is therefore Sandy gets no service. So that would be our answer. Now you have to be careful with the law of detachment. It's a simple law, but people misuse it all the time. In this next example, let's look at why this one actually doesn't work. So if Mrs. P goes to bed, that'd be me. If Mrs. Pryor goes to bed after midnight, then she is tired in the morning. I'm going to highlight our hypothesis. Mrs. Pryor goes to bed after midnight, then the conclusion is it's a direct result. She is tired in the morning, and I am here to tell you that is a true statement. I do have to go to bed earlier. So if we break that up, if I go to bed after midnight, then I am going to be tired in the morning. Now, in my next statement, I've got a true fact here also. This morning I was very tired. So Mrs. P is tired this morning. Now, does that match the hypothesis again? Well, no, it doesn't. This is the conclusion of that. And so if you look over at what we've written here, I'm tired. So does that mean that there was a reason for it, and only one reason is that I went to bed before midnight? And there is no valid conclusion. Actually, I did go to bed last night at 9 o'clock, but I kept getting kicked because my husband was sick all night, and so I was up and down with him. So that's the reason I'm actually tired. So in this case, there is no valid conclusion. And this was the law of detachment being used incorrectly. So let's summarize the law of detachment in the way it's correctly used. In the law of detachment, you're going to have two statements. And one of those statements will be an if-then kind of form. So P implies Q will be one of your statements. And then in your second statement, you will have some reference back to the hypothesis. And therefore, the valid conclusion that you can make has to do with the conclusion of the original statement. This is the correct way to use the law of detachment. This is the wrong way to use the law of detachment. So be careful about this. If somebody's trying to convince you that you've got these two statements, P implies Q is your first one, and Q happens, therefore P must have happened, that's the wrong way to do it. You have to see a link between your hypothesis in both statements, and then that leads you to the conclusion. But it can't go the other way. You can't have some statement about the conclusion and try to back it up to get the hypothesis. So be careful about that. All right, let's move on to the next law. The next law is called the law of syllogism, and sometimes this is called the chain rule. Might be easier to remember as the chain rule. The law of syllogism works this way. Let's read through this example. If Rex goes to bed late, he will be tired in school. If Rex is tired in school, then he will fail his quiz. So let's do some highlighting here. Our hypothesis of our first statement is Rex goes to bed late. And the conclusion is he will be tired in school. And let's write that out. Rex goes to bed late, and that leads to he's tired at school. Now the second statement is also an if-then form, but notice this. The hypothesis of this one, Rex is tired in school, that matches the conclusion of the first one. And then that leads us to a new conclusion. He will fail his quiz. So if we summarize that in a chart, we're looking at tired leads to failing a quiz. So the link here, or the chain, is the fact that we have our conclusion of our first statement and our hypothesis of our second statement are the same thing. So this is sometimes called cut out the middleman rule. That means that we can just cross out all this stuff about being tired and we can make a new conditional statement. And that new conditional statement would be to say that if Rex goes to bed late, then he is going to fail his quiz. Let's take a look at another example. If it is October, then it is fall. And if it is fall, then the leaves change color. So October implies that it's fall, and fall implies that the leaves change color. What valid conclusion can we make? What valid statement can we make? We're combining these basically into one statement. The middleman here is that it was fall. And so fall on both parts can cross out, and we have a new statement that says October implies that the leaves will change. So in written form, that's going to read like this. Therefore, if it is October, then the leaves change color. Can you do the law of syllogism wrong? Well, we're going to see you can from this last example. Let's break these down into hypothesis and conclusions. If it is raining, then it is cloudy outside. So let's say raining implies cloudy. And our next one says if it is raining, then the sidewalk is wet. Raining implies wet sidewalk. Can we make a new statement out of these? Well, this is a no valid conclusion. Just because it's raining, it will be cloudy outside. That's true. And if it's raining, the sidewalk is going to get wet. That's true. But does that mean something like if it's cloudy outside, then the sidewalk is wet? Well, no, it doesn't have to be raining. And so the problem is we didn't see a connection between the raining and the raining switching places. It didn't chain me over from one end to the other beginning. So this is not a valid conclusion. So here's the breakdown of the law of syllogism. We have two if-then statements. P implies Q, and Q implies R. And in each of these statements, we find the conclusion becoming the hypothesis in our chain. Therefore, we can make a new if-then statement that starts all the way back at the beginning with P and implies or leads us to R as our conclusion. The way that this is done wrong, so you want to be really careful not to make this mistake, is when you get your P implies Q, and then another statement, P again, implies a different conclusion, to try to make some statement about Q and R would be incorrect. You can make no valid conclusion about those. There really is no valid conclusion. There's a few here to try on your own, so give these a shot.